Good afternoon to you all. Welcome to our third webinar. My name is Grace Choto. I work for AHDB Horticulture as a knowledge exchange manager on vegetables. This is our last Microbials webinar in a series of 3. So our first one was on Friday, 1 March, where we covered risks of microbiological contamination during production and how growers can mitigate against the risks. We also gave an update on chlorate and perchlorate legislative changes. Last Friday, on the 8th of March, we covered commercial studies work that was done in Spain, where chlorine dioxide treated water and electrolyzed water were used for irrigation. The focus was on the impact that the irrigation had on chlorate and disinfection byproduct accumulation in outdoor and protected leafy salads. Today, we are looking at the challenges of chlorate testing. We will go over the results of an AHDB horticulture-funded study on chlorate testing and get an understanding on why the Food and Bioscience Industry Group is advocating for chlorate to be regulated under Contaminants Legislation. We have 42 registered, but they are not yet all here. We have muted attendees' microphones to avoid picking up any background noise. Speakers will give presentations, after which I will pose all submitted questions to them. Listeners, please type in questions and any evaluation or feedback that you might have on these talks. We welcome all feedback on the webinars and on the work that we do on fresh produce safety. So please do type in your thoughts as well and your comments, just generally on how we are doing on this topic. For we aim to help farmers and growers to produce trusted, safe food. Feedback will help us in the planning of our future events. So I am just going to introduce you to our first speaker. Mabel presented last week. So for those who joined us last week, it will be the same introduction, but we have new people on today. Mabel Jo Munoz has a pharmacy degree and a PhD in biology. She's a full research professor at the Food Science and Technology Department at CIBAS Institute in Murcia, Spain. Her research activities are related to quality and safety of fresh produce, particularly leafy salads. Mabel coordinates an expert group involved in fundamental and applied aspects of pre-harvest and post-harvest factors affecting quality and safety of fresh produce. One of her main tasks is the control of microbiological and chemical contamination during fresh produce production, processing, and storage. She's the leader of national and international R&D projects with public organizations and private companies. Mabel is speaking on issues pertaining to fresh produce chlorate testing. And the reason that we put on this talk is that there was really this concern that growers are getting all sorts of results from different labs, or sometimes of the same samples or what they consider to be a same sample, and getting different results. And so she's giving us a background which is not too technical, so that we can just get an understanding of where the differences in testing results might be arising from. So without further ado, really, I am moving on to Mabel, who will be speaking on next. I hope you can all see the screen. Viewers, you can type in questions or feedback. I'll be able to see them so that we can correct things if things go wrong. All right, Mabel, over to you, please.
Thank you, Grace, for your introduction, and good afternoon. So I will cover some issues regarding the chlorate testing for fresh produce. As Grace said before, growers are reporting that they are getting different results depending on the accredited laboratory they send their samples. So this is a big issue because in these accredited laboratories, they are using accredited methodologies. Particularly for chloride testing, they are using the reference methodology, that is the one you can see here at the bottom. That is a quick method for the analysis of highly polar pesticides in food of plant origin, and this methodology is based on a SPLC mass spectrometry analysis that involve a simultaneous extraction with methanol. This methodology is called the QPPE method. And this is a version from March 2015. And in these accredited laboratories, in most of them, they use this methodology. And also they use other in-house methodology based on the same methodology, SPLC mass spectrometry. So it's very important what the growers have these different results and why they have these differences, because that's make that the growers can comply or not with the current statutory for the maximum residue levels. That's, as you know, the permitted for chlorate are very low, 0.01 milligram per kilogram. So we evaluated the different reasons why the test results may not be accurate. And we cover different reasons for that. The first one is that there must be some differences and difficulties in extracting the vegetable, the plant tissue, in particular for green fresh produce. And we are examining this problem. And yes, we think this is a really important problem, and chlorates are not really extracted from the green tissue, but it's not only from green tissue. We have also a lot of difficulties from red tissue, such as red lettuce or other types of cabbage, red cabbage, etc. And also for other commodities with some difficulties in filtration, for instance, some cereals. So the differences in the samples, in the different fruits and vegetables can make important implication in the analysis of chlorates. You can see here in this graph I showed you last week from the results of my group. Then these two graphs show you the chlorate content in 2 red lettuce cultivars. You can see here in these two graphs there's a big bar that means higher chlorate content after storage compared with some samples just at harvest or after processing, after washing and drying. So the reason for that big increase is because of the differences in the extractability of the samples. In this case, after 9 days of storage, the samples were with more decay, with loss of visual quality and more deterioration. And in our lab, we were able to extract more chlorates than samples after harvest. And thus I put this graph in order for you to understand that it's very important, the extractability. You have to recover all the chlorates for the samples, and sometimes, depending of the freshness of the tissue, this can change the results. And this is an important issue. Another reason why the test results may not be accurate enough is because they need to fine-tune the analytical equipment. For instance, then there's some equipment that can be only sweet points with experienced persons. And yes, we agree that this is analytical equipment that is very sophisticated, and only experienced persons can run successfully this type of analysis. And in this case in particular is a liquid chromatography coupled with a triple, quadruple mass spectrometry. And this is a very sophisticated technique for the analysis of complex matrices due to the high and excellent selectivity. You can see here that under this HPLC analysis, the detection and the quantification is by mass spectrometry. You can see here there's the chlorates that contain a chlorine, 35 chlorine. By these fragments, we quantify the chlorates. Sorry. But in the nature, there's also a chlorate 37. So this fragmentation, and based on this fragmentation, why we quantify the chlorates. So it's important to know the way of this analysis and detection by mass spectrometry. Another reason is the need for the technicians to follow a procedure. And this is very important because the procedures in particular for the chlorate analysis must be followed very precisely. For instance, in our lab, we validate this methodology. In our case, 2 technicians follow the same procedure. Then it was, as I told you, this method I already mentioned, and we follow this guideline document. Then these guidance documents is specifically for the analytical quality control and validation of the pesticide residue. Under these guidance documents, you can follow why the methodology must follow a linearity, a sensibility of the methodology, the accuracy, and the repeatability. So we follow all this, and I will show you some information for you to understand that in any lab that is checking, in this case, chlorate and analysis and the test results must follow this procedure of the validation of the methodology. In this table, you can see for 3 different plant tissues, lettuce, carrots, and spinach. You can see here we obtain the linearity, okay, versus the concentration of chlorates. We have a signal, and all these points were close to the linearity. Also, we check the limit of detection. You can see here the data, and also the limit of quantification. So we validate this methodology in our lab as well as in other accredited laboratories. Also, we did the accuracy, the recovery assess. This is not important for me to go much into detail, just to also to understand that this is the normal procedure for the validation of a methodology, and also the repeatability of the technician intraday and also interday. They have to be very precise for the recovery and set all this methodology is really running well. Okay, another reason why the test results may be not accurate is because of the differences that the experience makes. And that is a skill to do this analytical analysis for chlorate. But we don't think this is really needed. There's no really essential skills to do this analytical analysis for chlorate, but it's more on the protocol of all the extraction and all the different steps. I will explain you later. And the last reason is why for instance, the recovery of the chlorate for the validation of the reported results may be quite low. And this is important. You have to understand that the recovery of the chlorates from the tissue maybe is too low, and this can be the reason why we obtain different results, different, let's say, as I told you, the different quality of the samples, and so the chlorates are very difficult to recover from the analysis, and you can see that when you spike with a external chlorate, with a standard chlorate, you add to your samples, and you have to recover all the chlorates that you have added. And in fact, in this regards, growers are now being asked for the recovery data in these laboratories. If they don't trust the result, they will ask for this data to see that in these laboratories they are doing that recovery after spike the samples. And this is what they do, and we do in the lab. It's called the standard addition approach. And this is a methodology of choice when there's no an internal standard, normally to compensate that the matrix effect, meaning that the tissue can affect the recuperation, the recovery of the chlorates. The labs normally do these kind of approaches. Then in this figure, you can see you prepare a stock solution of chlorates, and standard of chlorates. You buy this, and then you add in different quantities to your samples. Okay, and in this graph you can see here, as increasing the mass of your chlorates, you can obtain the different signals you represent, and when this line cross this axis, you obtain the chlorate mass in your sample. Okay, this is the way. This is an approach of is called the standard addition. But I will explain you now all the improvements in this methodology for you to understand better and why we have improved a lot this methodology. So in our lab, we have different objectives for the chlorate analysis, because our interest was to validate, to put in place this technique with a SPLC, the ultra high performance liquid chromatography, tandem with mass spectrometry for the detection of and the analysis of chlorate. Our purpose was to set up these methodologies, this methodology for the quantification of chlorate in water and in leafy vegetables. For instance, last week I show you the data we obtained with the disinfection of irrigation water with electrolyzed water, and we were analyzing during the growing cycle of red lettuce cultivation. We were analyzing the chlorates in the water and the chlorates uptake by the lettuce. So it was very important to set up this methodology in our lab. So first of all, we compare with other official methodologies, like for instance, for chlorates in water, in drinking water, that is from the Environmental Protection Agency in the United States, and is the ion chromatography. But you can see in these chromatograms that for plant tissue is very, very complicated, because you have here many other anions and cations, and in fact the chlorates are very, very, very low, and that's make that this is not the let's say the methodology of choice for chlorate analysis, because of the lack of selectivity. We also study in our lab the stability of chlorate in frozen samples, because sometimes we have different experiments in the field and also in the processing plant, and we wanted to understand if the chlorates degrade in water samples and also in tissue samples. So we study, in this case, in this graph, I show you the results in spinach. Here is in water, we wash spinach with chlorates, and here is in the plant tissue of spinach. We store for 21 days at -80, and you can see here that in this case there was more or less similar. You can see here there were no significant differences between the different dates we sampling the water as well as the spinach were similar. But in other plant tissues, as for instance in this graph I show you in lettuce, this is in wash water we wash lettuce, and this is in the lettuce tissue, and you can see that depending of the day, at 14 days, you have higher content than initially. And even we store at -18, then it should be stable, the chlorate, we have different results, okay? And the same happened here. It's not understandable why we have here higher content than, for instance, after 21 days, because chlorates are very stable in the field during processing and during storage. So this is because of the methodology of analysis, okay? The same happened with carrots. You can see here in some samples from washing in the water from washing carrots, you have this huge variability in results, as the same happened in the plant tissue from the carrots was with the water containing chlorates. So this is really very problematic. Also, the most important is to understand the matrix effect. In these three graphs, I show you when you start lettuce or carrots or spinach. And in this case, there's two lines. This line means the chlorates in methanol. And this line show you the effect of, the concentration of chlorates in tissue, in lettuce tissue. When these are different, you can see here if there's a decrease in the signal greater than 20%, that means that there's an effect of the matrix. The lettuce affect the recovery of the chlorates. It's not the same if you analyze the chlorates in methanol or if it's in plant tissue from lettuce. There's not much differences in the case of carrots, but you also can observe some effect of the matrix in the case of spinach. In this table, you have here the statistical differences. This means that in the case of iceberg lettuce, in the case of spinach, there's an important matrix effect. And a protocol for testing the chlorate content cannot be never affected by the matrix effect. You have to solve that, because otherwise that does affect the results. Okay. So what happened? And the good news is that last January there's a new method. The version I showed you at the beginning from 2015 has been updated with new improvements in this chlorate analysis. And this new version is really, decreasing all the problems I showed you before. In this, as I already told you, this methodology is for all the residues analysis, the very polar pesticides, and all are described here in this reference methodology, okay, including the chlorates in food of plant origin, such as the fruits and vegetables, cereals, and so. The most important improvements I wanted to mention in order for you to understand that from now you are not going to have differences in the results if you send them to one or to another accredited laboratory. And one of the improvements is the sample preparation. In this methodology is very well written, specifically the way of sample preparation. So the most important is to improve the homogeneity. For instance, if you can think of a lettuce, you in a romaine lettuce or cos lettuce, I think you called for cos lettuce, or a Batavia. You can see there's some midribs or photosynthetic tissue. This can affect for sure the chlorate content in the lettuce if you get more of the vascular tissue like the ribs, or if you have a sample more on the photosynthetic tissue. So if you really send to a laboratory your samples, in the laboratory they have to get a very homogeneous that represent your lettuce, your whole head, okay? Why they need? Because there's so much variability in some type of samples. So the samples must be mild. In first, for instance, we cut in large units of 3 centimeters, and then we frozen in liquid nitrogen, and then from the liquid nitrogen we grind these frozen pieces to obtain really a powder, okay? And from the powder we weigh the 10 grams needed for the extraction. So this was not really a requirement from the previous version of this methodology. A second improvement, as I already told you, we add an external standard of the chlorates, but now we don't need any more external standard. We call internal standard. Why? Because this you can see here in this table, we have a chlorate that is isotopically labeled. It's not with the oxygen 16, it's with the oxygen 18. And this is very important. As I can tell you here, I already explained you why the way we quantify the chlorates. And you can see here, this is the normal chlorate in your sample, okay? And we buy this isotopically labeled chlorate with oxygen 18, and these have a different fragmentation. You can see here the same retention time, but very different fragmentation. And so if we add this at the beginning of the procedure, we compensate for all the factors of the protocol. For instance, the recovery rates, such as the volume deviation, the analyte clauses. If we lost some chlorates, we also lost some chlorates from our internal standard. And also, for instance, the matrix effect I was talking to you. For instance, if we want to analyze the chlorate content in a lettuce, then I already show you why the lettuce have such an important, strong matrix effect. We add this internal standard, and if the matrix has any effect, it will also affect our internal standard. If we have a lower content, we compensate for that, and we will give you exactly the content of your chlorates in your lettuce sample. Okay. I'm not sure if it's, I'm explaining myself clear or not, but because I cannot see your faces, but I'll try to do my best. So in this image, I show you the most relevant steps for this protocol of the analysis. This is as I told you, this is the method, and this is a very fast overview of the most important steps we do in the lab. For you to understand that now, we weigh 10 grams of the sample, so it's not very high amount. That's the reason why I will emphasize the important thing you have to follow in the field, okay, or in the processing plant, etc., or in the supermarket. So we are now working with, as I told you, with a more representative, homogenized sample. Okay, so we do the extraction, and this is very important, as I already told you. We add this internal standard of chlorates. It's an isotopically labeled chlorate. Okay, we shake, for 1 to 15 minutes, we freeze out to completely frozen, even at -80 degrees. We centrifuge, we filtrate, and we analyze with the equipment I already told you. With that protocol, we avoid all the differences in the extractability, as already told you. Also, if your sample is, for instance, in pineapple with very high fiber content, we also reduce let's say, the impact of the fiber, and we recovery all the chlorates in the supernatant, and from the supernatant with the filtration, we are sure that we are analyzing the chlorates that are in your sample. Okay, we have been following this protocol, and now I can tell you that from our replicates we are getting a much more precise results. We are very happy with these improvements, and I'm sure when you send your samples to the labs, you will get more similar results. And now the last part is some of the recommendations for you for the sampling. For the sampling, it's very important to take the samples as more randomly as possible in your field. It's the same as with the microbiological, when you are taking samples for microbiological tests. It should be taken randomly within a lot. Also, it has to be very representative of from the maturity state and the quality that you want it really to analyze. It has to be, for instance, commercial conditions, not the very tight leaves, not the very old and let's say too mature. It has to be really representative of the crop. Also, you have to avoid differences in the water content. You cannot harvest very early at noon or let's say, in the afternoon. In some cases, you should really establish a protocol for harvesting your samples, for taking the sampling, and always in the same. If you are periodically taking some samples, you should also consider that depending of the time of the day, you can have different water content, and this can affect also the content of the chlorates. If you lose water, you will increase the content of chlorates per fresh weight. Okay. Also, during transportation, the sample should be protected as the same to avoid damage, damage during transportation, etc. And also, when the lab receives your samples, they should store under refrigeration. Of course, no longer than 5 days, they say. I should say they should analyze within 1 day maximum. And the quality must be acceptable for purchase. You can know, for instance, as is show you in this picture, if there's a high dehydration, they are not, let's say, adequate. The quality is really poor. So you should always send samples that have a good quality. And for the analysis in the lab, they should do all the preparation and the processing, the protocol, and within the shortest time to minimize the sample decay and the chlorate losses. So this is important for you also to check with the lab you are sending the samples to. And that's all for my side. So thank you very much for your attention. If you have any question, I will be happy to answer.
Thank you, Mabel. I'm looking at the question board here and there's no questions. Does anyone have questions for Mabel? If you have them, please sign them on. I've got one question in terms of sampling. If growers are sampling leaves, because you said like lettuces, they affect the matrix, will affect how much chlorate is recovered from the samples. They are doing it, at the right time of the day, which would be the right time perhaps to harvest, because obviously on a normal non-rainy day, would it be the same? If they harvest in the morning, for example, could they send that morning sample? Is you advise on a certain type of time for these things?
Yes, you are right. I should recommend to harvest at the same of the commercial samples in the morning, as you know, normally is with the humidity during the night, and so you have a very good quality in your samples, and you have also during the all day to ship to the labs and to the lab, and I would recommend in the morning.
All right, we've got a question here as well. What recovery rate of chlorate should we be looking for in a sample result? We recently sent samples and the recovery rate was 102%. Is this good?
100? 100?
102.
110. Very good.
No, 102.
102. Yes, that means a good recovery. Yes. I'm not sure if it's in my presentation the recovery. Probably now I can know the recovery. Is very good. 1.2. Yes, it should be exactly. This is a high accuracy and good recovery from me.
All right. So if growers harvest, let's say leafy salads, should they, and they wanted to separate them out and send, if they're using 2 different labs, do you recommend blending the leaf and then separating it and freezing it? What would you recommend if they wanted to find out what they're getting from different labs?
No, but I recommend just taking the samples without any damage to them, because as soon as the tissue is damaged, it can also affect the chlorate leakage, and so I suggest separate it into 2 batches, and very homogeneously from the same quality, let's say, going to one lab and another. But in the lab, they will manage to homogenize in, by frozen in liquid nitrogen and to grind. But for them, it's just to maintain, as I told you, protecting from the and avoid any damage on the product, particularly for leafy vegetables that sometimes are really let's say very young leaves with easily to damage.
All right. We don't have any more questions, Mabel. So thank you very much. I will now move on to.
Okay, thank you, Grace. Let me turn the microphone and thank you so much. Good afternoon.
Good afternoon. Thank you, Mabel. Yes, the next presentation is from myself, and I will try and bring this presentation up. But whilst I do this, this presentation is on the results of an AHDB horticulture funded chlorate in tomato testing study. I'll tell you a bit about myself just briefly. I joined the AHDB in April 2009 as a communications and knowledge exchange manager for all vegetables. So initially the role covered all of them, including those grown under protection and outdoors. But over time, the remit has changed to be specific on outdoor and protected salads and herbs, cucurbits, watercress, sweet corn. So all the salads and all the minor vegetables, and excluding the protected vine crops. But in addition to this, I also manage this microbials portfolio or contaminants work. And as part of that, we run workshops. And this year we decided to run webinars because we thought we'd just highlight people on legislative matters. And we thought this would be the best way because we didn't want to worry about attendance since it's all very high level things that we wanted. So essentially, I'm responsible for helping growers to keep fresh produce clean during production. I hold a Bachelor of Science degree in agriculture with honors in crop science and also a master's in post-harvest horticulture. So that's a bit about me. Let me just move on to my presentation by change presenter. Show my screen. If delegates, if you can't see my screen, please let me know by typing in the question box. Okay. Okay. So I'm just going to put that into slide mode. Please do type questions in if you can't see. Okay, so this presentation is really just a small study. Not a lot of money went into it at all. Let me check for questions. We can see it, Grace. Thank you very much. I'll unblock that. Why did we undertake the study? As Mabel has already pointed out, there was grower concern that different UCAS accredited labs using different accredited methods for chlorate testing were giving different results, and there was a bit of evidence. There were some reports, but anecdotal, really, of significant differences in results of similar samples that were sent to different labs. So what did we do in this study? It was tomatoes were used as a case study. A classic round tomato variety called Graciano on a root stock called Optifort was the main subject for testing, but there was also a cherry variety called Nebula, which was also on the root stock Optifort, which was tested. Plants were grown under protection on coir substrate, and they were grown hydroponically using treated bore water, and they were grown and treated in the same manner. So those are the details really on how these plants were managed. So you've got them, the Graziano there is in a specific house, a glass house, definitely, and you've got nebula there, and there you've got when the plants were delivered and when they were first picked. So you can see from that top table that we had nebula just, it was like a month earlier delivery to Graziano. They were then grown, and then obviously nebula was then harvested first. The first pick was on the 9th of March, and then for Graziano it was on the 13th of April. And then the chlorine compounds that were used across the board are those that I mentioned there. You've got sodium hypochlorite, potassium chloride, calcium chloride, just all the chlorine. We thought we'd put everything. Obviously, some for disinfection purposes, like Chlorius 2, some as nutritional things. But in terms of bore water treatment, the bore water was abstracted and stored in a temporary storage tank with hypochlorite being added to the bulk storage tanks to help with the precipitation of iron. And then a chlorine compound consisting of freshly produced hypochlorous acid was used at the recommended rate, and this was then injected into the water supply in line with the addition of nutrients, so as the water flowed to the plants. So in terms of how the samples were collected and treated, each sample that was taken for chlorate testing was from the same vine, in the same glass house. So same vine, and then samples were in end of season fruit with the last pick there. In December, I can't see part of my screen, sorry about that. Samples were harvested on the 7th of December and packed into plastic bags, food safe seed bags, with no washing or any other treatment. And they were immediately frozen pending dispatch to the chosen labs. We don't really know how the samples were treated upon receipt and before they were actually processed, because as Mabel has pointed out, there are issues there that could affect what they recover. So the two labs that were used, this one, we used FERA, and they used that QUPPE methodology. And FERA, I've said this method, and Mabel has pointed it out, is the method developed by the European Reference Lab and used across the EU, and that they use state-of-the-art equipment and their national reference lab, which are part of a wider EU-wide network and forum of labs where such issues are discussed, and they have experience in this area. And FERA asked that where growers are, they advise that where growers do get different results, they should ask for the labs to provide their proficiency data. We also sent our results, the samples, the split sample, to Concept Life Sciences. Again, both of these are UCAS accredited laboratories using UCAS accredited methodologies. And Concept Life Sciences explained that there will be variation within results because of the testing and preparation methods will vary. And then there might be, different machines as well might be run. But they said again, they've got a technical pesticides team and they are analyzing for pesticides. They've done this for years and they've not received any concerns in the past. And they are very happy for growers to get in touch with them if growers have issues. So what results did we get? Those are the results. As you can see, most of the samples are from the Graziano variety. We've only got in that table one nebula sample, and those are the results across the labs. Where you've got most of the results, if you compared per sample, because if you remember, these were taken from each vine, sample per vine, they are very, very similar. There's not much differences apart from that one, Graziano 4, which is like 7 times. So, I mean, that's what we got. It's a small sample. We are expecting more results. We're hoping they would come in by today. They haven't, but they will come in next week. But basically, these labs are getting uniform results. So what can we draw from such work? Very little. It's a very small study, and without other results, It's very difficult to say what we could, to recommend anything really, or to come up with conclusions, because results are similar on the whole. So what are the chances of getting large differences? 1 in 11. According to that, we don't really know without going into a big piece of work. But also there are other things, as Mabel has already spoken about, there are other things that could be leading to these differences in results. But hopefully with this new method that Mabel has highlighted, the labs will be able to recover similar amounts of chlorate for the same samples. So what to do? So when I was putting up this presentation, because this is what growers often ask, so what do I do about it? For now, it's really hard to say what to do, because we are doing this study, and we can broadcast the results out so that you know what is happening. If you wanted to, you could do your own studies, because one of the things we've heard from growers is they're using a particular lab, and we don't know whether the labs they're using are UCAS accredited, are using UCAS accredited methodologies for chlorate testing or not, because these labs sometimes they are UCAS accredited as a whole, but then for the methodology they are not UCAS accredited. So if you're using other labs, we would probably suggest that perhaps send these samples to that lab and another lab which is UCAS accredited, like these two, a different lab, and then compare the results, and maybe repeat 3 times just to get in the reps, or just over the course of the season, to see whether you could also learn a lot about what's happening in your own crop, particularly for long season crops perhaps. And you could ask for recovery data, but maybe it's not necessary, who knows, because Mabel has said there is a new methodology that might be a lot better. And when you've done this, please send your results. I think we have a role to build a picture. We often respond to consultations on growers' behalf. We responded in 2015 to the chlorate consultation ban. This time we responded, although we didn't put a response to the main commission consultation, we actually pulled together data and backing evidence to say, they should look at these chlorate levels again. So we do a lot behind the scenes, which you might not see, because we have contacts within the commission, and we are sending these things. So whenever you do more chlorate studies, please bear us in mind. Just send them to me confidentially, and I will just pull them together so that we can build a picture as to where we go on this subject. So what to tell, and this is the other question I often get, they say, oh, Grace, my customer, a retailer, has got in touch, and they are asking me, they've got a high level of chlorate. What should you tell them? I think we've all got a role to educate our customers, whether it be those that are processing our crop, or whether it's a main retailer that's buying the crop as it is, the produce as it is. We have a role, because we're dealing with different people on the ground that perhaps don't understand the issue fully. So each one has a role to explain that differences in chlorate testing and methodologies is something for the European Commission to sort, and it seems they are trying to sort it because they've got a new method in place. It's not for any single grower or for any lab to sort. So you need to let them know that there are differences, and also question the validity of your customers' chlorate testing results. How were the samples treated? Use some of the information, because now you're equipped with Mabel's presentation. How were my samples treated? Well, I harvested them later in the day, so maybe more was recovered. Yes, obviously the labs will homogenize the samples and only use 10 grams. So you've got a role to question the validity. It doesn't matter who it is to. And then also, if you're being asked or being told that your results are way above what's permitted, please let them know that the Commission proposed in January 2019, and the 0.01 milligram per kilogram, although it's statutory across the EU, the reality is, it's if very high levels are found, it's really on a case-by-case basis, and they'll look at the risk that has on the consumer. So it's not like if you get a level that's high, you should worry about it. So do educate them. It's something that we as AHDB are trying to work with you growers to sort as well, and we are working as well with the Commission and with our legislators. So it's something on our radar. We have responded. A number of crop associations have responded to the Commission consultation on chlorate, as well as large bodies. So there's an enormous amount of effort that has gone into this, and it's still progressing. So that's about it. I hope I wasn't too fast, but I would like to thank the British Tomato Growers Association for they supported this study, and the tomato grower contributed their tomatoes and efforts into this study, as well as this presentation on behalf of growers. Thank you very much. We need a lot of growers to work with us on issues that cannot be tackled by one single grower, or legislative issues. And also just to thank Nikki Harrison, who's the AHDB Horticulture Protected Edibles panel manager, who actually managed the work. I just presented it. And so if you have any questions, I will take them now. Okay, it seems we have a question. Okay, this is just I'm sure you can see that. Do we have any other questions? I'm gonna hide my screen now so that I can look at the questions. And whilst I do that, I'm changing the presenter, and our next presenter will be Karen, but I'll be checking for questions before I hand over to Karen. All right, so I'll have a look at the questions again. Okay, so one of these is this. There is clearly still a lot of work to do before MRLs can be enforced. Yes, I would like work to have gone into this. We had actually proposed work to understand irrigation practice and chlorate accumulation in produce, as well as to undertake nationwide statistical data gathering on chlorate. But we had to shelve it because at that point, when we wanted to do the work, we weren't aware that the Commission was well advanced in terms of chlorate MRLs, in terms of their discussions. But certainly, in order for us to develop best practice, because chlorination of waters for irrigation particularly is really, or even for processed waters, is for microbiological safety. And, we've been consuming chlorate in municipal waters for ages, and people are living longer. So yes, we can always do better in terms of health, but it needs to be really reasoned argument that's supported by research. Okay, and then partly due to sampling and storage variation, and partly due to lab variance, and perhaps even time of year and stage of crop. So there are many factors. I do agree. There's many factors. But yeah, we are, in spite of Brexit, I think those MRLs, our own government will probably follow the same MRLs, because it's a food safety issue and it's a human health concern, but there are factors that should be taken into account. Okay, I think that's about us. Let me just move over again to our next presenter, who is Karen Goodburn, MBE. Karen is the director of the Chilled Food Association and chair of the UK Food and Biocides Industry Group. She's a chartered scientist specializing in chilled food science, technology, and regulatory affairs. Karen's career has included working both in-house for the Chilled Food Association and numerous other trade associations, and as a consultant advising government and professional bodies on policy, safety, and supply chain issues, providing technical guidance to manufacturers and representing the industry both in the UK and around the world. Karen is the director of CFA, and he established the Food and Biocides Industry Group, which represents some 20 UK trade and professional organizations from farm to fork on biocides. And she's covering, her talk is on why the Food and Biocides Industry Group, she's giving the position on chlorate regulation. Karen, we can see your screen.
Okay, that's great. That's a good start. And you can hear me as well?
We can hear you as well, Karen. You can go for it.
All right, thanks for the introduction, Grace, and for the invitation. And afternoon, everyone. So I'm going to give a quick overview of what the Food and Biocide Industry Group is about and what we're up to and what the challenges are we and everybody is facing. With a particular focus on chlorate really at the moment, but I'll just give a load of context and possibly a bit of hope as well. Can't promise everything, but we can do our best. And Grace, just so you know, I've put about 3 more slides in just to illustrate brief points, but it doesn't expand it greatly. Okay, so who are we talking about? Food and Biocides Industry Group, FBIG, and the regulatory players. There's many organisations and governmental departments involved in this in UK and European Union. We've got many layers of regulation going on, which has brought about conflicts, which is very stressful, but we're trying to resolve it. Landed a problem on the Commission. And what do we actually want? And when do we want it? Now is the answer. So who are we as the Food and Biocides Industry Group? Well, we've actually been going about 5 years now. So we've got a common page at chilledfood.org/FBIG on the top right of the screen. And as Grace said, there's about 20 organisations involved in different ways. The NFU through to the hospitality and retailers, and then BACS, the biocides industry, one of the biocides industry associations as well. So it's all the food manufacturer, chilled, frozen, ambient, meat, fish, dairy, fruit, veg. Yeah, so everything's pretty much covered by it. So what have we done over these last 5 years? Well, we have a position paper on what we want regulation to look like, because at the moment there's a big conflict between assuring hygiene and then residues or traces. We produce guidance on cleaning and disinfection and what biocides are suitable for what surfaces and applications, what the downfalls are, downsides of various ones as well, and how to clean and disinfect. And the guidance also has a list of the PT4, the product type 4 biocidal actives that are in the Biocidal Products Directive, which are the only actives that are going to be available to us. And in fact, no more will be added, and only biocides will be taken off if there's no dossier to support their continued use. We had the Plant Protection Products refits activity, made a submission to DEFRA on that, I believe it was last year. I'm not entirely clear where that's gone, to be honest. What's happening with the PPP refit? It certainly needs to be sorted out in terms of biocides used for hygiene that once were pesticides. Biocidal Products refit, there was some activity 2017, and we've secured a 3-year trial, which meant that not only do you look at the chemical residues and traces, but you have to consider what you might be doing by not having a biocide available to assure hygiene. That's the approach the WHO takes. They say, okay, you can take chlorine out of water, but how many people are going to die from cholera? So that sort of assessment is now in the European Commission's guidance on how you go about things, but only until March next year. On the Advisory Committee for the Microsafety of Food, which advises the FSA on food safety on the micro side, of course, we've pushed them to do a risk assessment. This has been going on for several years now. We've pushed them to do a risk assessment on what happens if we lose effective biocides for hygiene just because they're regulated out of existence as they used to be a plant protection product. And we made a submission as FBIG to the ASMSF last autumn because there's some signs of activity finally on that front, although it's extremely late in the day. On the European Commission chlorate MRL proposals for foodstuffs, we've coordinated UK submissions and press for comment from around the world, and 64 organisations wrote in pretty much with one voice in February and opposed the European Commission's proposals for MRLs on foods, pointing out hygiene issues and all sorts of other things I'll come across. And our industry stakeholder network, FBIG, has monthly conference calls so we can all share information and decide on strategy and what needs to be done next. So that's roughly us. So on the next thing, we're in the top left corner, and we have BACS, British Association of Chemical Specialities, directly engaged, and there's a line across to the UK cleaning products industry. We have BASE going down on the left. BASE expert groups, and particularly the hygiene one, though that hasn't met for a good 18 months. There's linkages in through to the FSA, DEFRA, we mentioned ACUSF, the DWI, because the Drinking Water Directive is up for grabs at the moment on chlorate. So FSA deals with residues, food hygiene policy. HSE represents the UK around the table in Brussels, and they do the negotiation and they enforce on residues. So the FSA with EHOs, they enforce on hygiene, nothing to do with plant protection products in that respect. HSE deals with PPP. In the middle of this, we've got our European federations. I've just put in the European Chill Food Federation and Food Drink Europe as a couple of them, but there's a whole network of them. And CEFIC is one of the biocides associations or federations. So we're linking with them and driving stuff from the UK, because not many other countries are really active on this. I can't understand why. On the right-hand side, we have the European regulators. So we have ECHA in Helsinki, which deals with implementation of biocides legislation, the BPR. Then we have the European Commission halfway down on the right in Brussels, which deals with overall policy, but different bits dealing with water and plant protection products and hygiene don't really talk to each other. And then we have EFSA in Parma in Italy, which does risk assessments. And only the Contam panel looking at contaminants has looked at chlorate, for example. Nobody on the biohazards panel has looked at chlorates and the consequences of if we were to lose chlorinated water from the system. So we've got Helsinki, Brussels and Parma, and they don't necessarily talk to each other. So that's all good so far. So just to recap here, biocides ensure food hygiene and protect public health. You have to use them responsibly, because nobody wants to have traces carrying through into food that you cannot avoid. So this is used worldwide. We've got 3 different sets of legislation that could relate just on the biocide itself. So the BPR, regulation from 2012, pesticides legislation from 2005 relating to basically commodities, and that's hazard-based legislation. So it's calculated by looking at what are the residues found on crops, etc., and then taking a percentile of that and setting a limit there. So it's nothing to do with food safety. Contaminants legislation does take into account dilution and processing and concentration, and that is risk-based. I'll just go through these briefly. The whole background of this really is, why do we want to keep cleaning things? The answer is so we don't kill people with microbial contamination. So I've put up a table here, which was from a piece of work that was referenced in the Safe Smoked Fish project for Food Standards Scotland, the best part of 7 or 8 or more years ago, and I was involved in that one. And you can see on this, looking at the quats, quaternary-ammonium compounds along the bottom row, these figures on the third and the 5th column, these are log reductions on artificially contaminated surfaces, either in the absence of protein residues, where there's been effective cleaning, or where there's poor cleaning. And we can see the most effective by far on these, after effective cleaning, is quats against listeria. Massive reduction, millionfold reduction on contaminated surface. If you don't clean properly, you get a sort of, say, a 10-fold reduction in efficacy. So it's still pretty high, about 100,000 plus. Then you scoot down, or scoot up the table, and you can see hypochlorite. It's pretty effective when you've cleaned off the protein. Then follows peracetic acid and other halogen stuff. Quats are now being regulated as a PPP, and the MRL came down from 0.5 to 0.1 a couple of summers ago. And so a lot of people shifted out to using quats in high-risk industry, ready-to-eat, chill-prepared food. And what have they gone into? Because the fear is, okay, we're going to get done under PPP legislation for something that carries over from surface after you use it for purposes of hygiene and ensuring safety. And quats are really low toxicity. So hypochlorite comes next in the frame, and this is where chlorates will arise. Can arise from poor storage, or you've had it out too long, it's been in the light, the wrong temperature, etc., etc. or it's been diluted too long. And we can see we can't lose these things because we're going to leave everything open to listeria. Now, big thing here is that on the chlorate stuff in particular, the work's being done really by non-hygiene people. It's done in the plant protection product world of chemists. And there's nothing wrong with chemists, but the world is bigger than chemistry, and we have to think of why we're doing this and how do we stop doing the wrong thing. The wrong thing is causing listeriosis and other diseases. Hygiene is absolutely paramount in listeria control in factories and everywhere. It forms biofilms, and you really need to keep on top of hygiene to stop those being formed, as they will just contaminate a whole factory and break off and contaminate food. Very difficult to remove and establish biofilm. If you look at all the listeriosis cases from around Europe, broadly Europe, with EEA and EFTA states in as well, you can see that although listeriosis comes out of only 2,500 confirmed cases for 2017, the last data for which is solid data from Europe, you can see it's 100th of the reported confirmed cases of CAMPI. But when you look at the death rates, so on the right-hand side, the fourth column from the right, let's look at the hospitalisation rates, proportion hospitalised. You can see 98.6% of those 2,500 or so people who presented with confirmed listeriosis were hospitalised. This is a really serious disease, causes sepsis, meningitis-type symptoms, spontaneous abortions, stillbirth. This is not just diarrhea and vomiting. And in the UK, 80% of people who've reported to get it have this more serious form. If you're robust and healthy and you probably don't have a big exposure, then it might come across as slightly feverish DNV, but otherwise we're talking about sepsis and death as an outcome in normally 20 to 30% of cases across the globe. So in looking at the deaths, the third column from the right is reported deaths across these 30 or so member states and EEA and EFTA. And we can see that listeriosis caused 225 deaths in 2017, which is pretty much the same as all the top 4 above them in terms of number of cases. So half of the deaths out of the top 5 organisms were caused by listeriosis across Europe. It shouldn't be happening, and we need hygiene. We need to have biocides that are used effectively and appropriately to get on top of this and stop people dying. We've got the case fatality rate here, the second column from the right. So what I've done on the final column is just compare the listeriosis fatality rate with the other diseases. And you can see that really you're 345 times more likely to die of listeriosis if you got it than if you got CAMPI. And even S-tech infections, so sugar toxin producing E. coli, it's 28 times more powerful or likely to kill you. So we're not going to mess around with this. But the question is, how on earth can this be not on the agenda when you're talking about regulating things like chlorate and quats? So when you look at the countries where listeriosis is prevalent, it becomes a bit more stark, and there are strong patterns. All the countries with a red background are above the EU rate for that particular year. The middle white bar is the EU rate, which is about 0.5 per 100,000 population. And then the green blocks are the countries that for that year were below the EU rate. So you can decide where or where not to go on holiday. Or if you do decide to go there, perhaps don't eat high-risk food like ready-to-eat meat, fish or dairy products that haven't been produced properly. So UK comes out in the bottom chunk. We're hovering around 0.3. Something interesting happened between 2016 and 17, and the rate dropped from 0.31 to 0.24. If we can maintain it that would be great, because we're the largest country to have such a low rate, and it's persistently low as well. It's been like that for a good 15 years or thereabouts. And the countries that are in the top block are mainly Scandinavia and the sort of delicatessen charcuterie consuming countries, and it's not surprising. And of course Spain's there, and my personal theory is that there's tapas sitting out in the warm as we speak. It's all ready to eat. So we can see countries if specifically I'm thinking of Germany and Denmark, who have massive listeriosis rates consistently, far higher than the UK. Their scientists are on the European panels saying we need to get rid of residues and traces of biocides, and they're just focused on that. And meantime, a disproportionate number of people are dying in their countries because they're not cleaning, disinfecting, and making the food properly. Obviously, you can see that from the cases here. So there's a real disparity between the countries pushing for control on biocides and those that actually have high listeriosis rates. So there needs to be some waking up and cross-pollination of thought going on here. So the regulatory environment then. So what we got: food safety, biocidal products, PPP, and contaminants. So it's four main things I'm just going to scoot through. This is a nice diagram from the European Commission, and the outer circle shows Food Hygiene Law Regulation 178/2002, which says food must be safe. And then the Commission has drawn the biocidal products regulation in the middle and showing how it overlaps with PPP, baby food, pharmacologically active substances, feed, contaminants, I've added in the later reg, food contact materials, and anything undesirable generally. But it doesn't overlap with hygiene of foodstuffs legislation, neither the meat or products of animal origin 1853 nor 852, which is across the board generally, and produce as well. It doesn't overlap with feed hygiene or food additives either on the biocide side. But as I mentioned, we had a 3-year interim position agreed by the European Commission in March 2017 to take the hygiene aspects into account when you're considering approval of biocides, or we say reapproval of biocides. So we got that for a year, just 1 year. Who can say what's happening? If anybody has a crystal ball, let me know. So just looking at the general food law, it says food has to be safe if you're going to put it on the market. So if it's changed hands, you've given it away. FSA has been recently saying that really if you make the food, it's on the market as far as they're concerned. I can't quite see where that comes from. And it says food should be deemed unsafe if it's injurious to health or unfit for human consumption. It could be mouldy or something. So you have to think about the intended use of the food, and some of these things you might be diluting with water out the tap, which will contain chlorate. Conformity of a food with special provisions, blah, blah, blah. That's all right. It doesn't stop member states doing things out with the law to say, I'm going to take special measures to protect the population in my country, whatever. So they can do different things. But food has to be safe. Food has to be safe, globally safe in every respect. Then we've got general food hygiene law. And it says primary responsibility for food safety sits with the food business operator. So you have to get it right throughout the food chain, and you have to use HACCP, good hygienic practice, and all of this should reinforce your responsibility. So you need to keep things clean, because Chapter 5 says so. Cleaned and where necessary disinfected, and at a frequency sufficient to avoid any risk of contamination. We'll talk about hygiene here. So you're required by law to clean stuff and use biocides. The biocidal products reg says what criteria must be met for a biocidal active and derivatives to go onto the market. And this protects the environment as well as humans and animals as well. So I've mentioned PT4 is the stuff that's allowed for food or feed. Nothing's been added to that list. There's about 50 actives on the list. And if dossiers aren't pulled together by manufacturers of those biocidal actives, and these have been done through consortia in Europe, then they won't be supported and they'll go off the list and they'll disappear forever. So as I mentioned, there was no impact of hygiene, food safety and hygiene considered in the whole equation about biocidal products safety. It was all looking at residues, consumption of residues and traces, not how many lives are saved by using this thing for microbiological reasons. So the HSE supported the UK, well, an F-big position. We had a lot of support from the HSE going back a number of years, and they were lobbying into the SCOPAF and other groups at Brussels, and were, I think, often a lone voice. Denmark, Netherlands and Germany were seeking MRLs based on best practice and the precautionary principle without consideration of how many people will die if we've got listeria all over the place. So we've got this situation where there's more like regulation under sort of contaminants legislation at the moment of biocides, taking more things into account just than residues or traces. And I have no idea whether that will extend beyond March next year. So the PPP lot, which you'll probably be most familiar with, so this regulates materials that are intentionally added for a specific purpose, and the MRLs are set on the basis of surveillance and then setting it as the 90th percentile level found. It's not really anything to do with food safety here. It's about good agricultural practice and trying to bring down usage by, finding subsequent years lower and lower percentage. Unfortunately, it doesn't really fit when you get to chlorate because it's in the water and you need to use hygienically treated water from irrigation onwards, by the way, in food manufacture as well. So we have this issue where it's just focused on chemicals and residues. It's not even looking at traces on surfaces in that sort of way. It's talking about combinations of specific PPPs and commodities. We do not have sandwiches, cream cakes, all this sort of stuff listed in the back. They're just not listed in the back. And I know the HSC has been looking at applying it in different ways and working on what proportion came from the leaf or whatever, but it's really complex. But none of those sorts of composite foods are listed in the back. Fish isn't covered either. So dual-use biocides, so biocides used as a plant protection product and for hygiene purposes, have a real problem with this approach in legislation. Really do. And I'll just mention that the default MRL is a limit of determination 0.1 ppm or milligrams per kilo. As Grace said, the proposals are being consulted on. It ended on the 18th of February, and we had 64 organisations from around the world saying this really doesn't work for chlorate, So the question is, why apply pesticides law to biocides that are only being used to assure hygiene? And this is a diagram of a bit of the problem with all the different bodies that you're trying to get to talk to each other. And I should say that in the diagram, you can get pesticides overlapping with other classes of biocides. So you can have wood treatment agents and things. There can be a whole myriad of different categories of things that overlap, and they will be dual-use biocides. But in this, we're really talking about quats and chlorates in particular at the moment. I have asked HSC a couple of times over the years, what other materials are out there that would be considered to be regulated or need to be considered to be regulated under the PPP? Because the rule is, if it's been used anywhere at any time as a PPP, that's the legislation that regulates it. And as I said, the default MRL is 0.01. So we need a bit of rationality coming into this one, because if we're going to stop being able to clean containers, equipment, floors, treat water, including drinking water, water for washing hands, cleaning for transportation and utensils, things are going to start falling apart. So the Contaminants Regulation is different from the Pesticides Regulation. So this relates to recognition that things occur in nature or from raw materials on which food is derived, in most cases unavoidable, as it may come from, pollution, growing and harvesting conditions, processing factors, concentration, drying, etc. Importantly, this relates to things that are not intentionally added to the food. So it's the other side of the coin from the PPP. And here we have maximum levels, not MRLs, and they're set on the basis of risk through scientific advice from EFSA and previously SCF. And it's designed to protect the most sensitive groups, the young, the elderly, pregnant women. So this is all based on a sort of cost-benefit thing, but really on the risk of the contaminant versus any potential benefit of food or whatever put it into the food. And then it takes into account feasibility of detecting through chemical analysis as well. So this is much more, this is a risk-based approach, and it's much more accommodating for things that arise naturally or that you can't control. So at the moment it covers mycotoxins, metals. Grace asked me to mention there's a consultation on cadmium and data are needed on that, so I'm not involved in that, so I have to have a chat with Grace. Process contaminants such as 3-MCPD, which is a big thing in soya soy source many years ago and still pops up. Polycyclic aromatic hydrocarbons, PAHs, dioxins and PCBs, melamine, and nitrates. And there's a little exemption here for some lettuces from those rules. So you're familiar with the Contaminants Regulation in that respect. There will be a lovely home for chlorate and crops in regulatory terms in the contaminants legislation here, because we need to take account of concentration. We've got bioaccumulation and things going on, as you just heard, with leaf and tomatoes and the rest of it. So something that's happening naturally, why assume that it was all there just because somebody applied chlorate as a pesticide, which they clearly haven't done because it's been banned and it's not used. So this one, the Contaminants Regulation, is much more, let's say, forward-thinking, risk-based stuff. Going on my screen now. All right, so on chlorates, just a little bit on this. So back in November 2015, proposals were made by the European Commission, and we pushed back really hard on this because we said you're going to really compromise food safety because it's coming from the water. It's coming primarily from the water. Of course, there's some coming out of the ground where there might have been previous use of PPP, but really it's in the water from irrigation onwards. So it took 3 and a bit years then for the Commission to slowly working its way through, and they came back with, well, they did a big data collection exercise, and I understand that Germany put a lot of data in, and that they don't use chlorination in washing fresh produce. And there are other data from other countries, and other countries may not chlorinate the public water supply, but use UV and reverse osmosis or whatever they're doing. Are we really talking about ripping out the entire water infrastructure of the UK here to deal with a theoretical risk that doesn't really relate to anything in reality? January, amended proposals came out, and there was a big response, all saying the same thing. And my understanding is the Commission was somewhat taken aback and is wondering what to do. But of course, there's the European elections coming up in May. I think it's May. Was it April? Well, it's coming up. And there'll be a whole rejig at the Commission, so there's a lot of pressure to get this sorted before that happens. On the MRLs proposed, there'd be, through the AHDB work, and Grayson, I'm talking about it, it's a feeling that could be consistently achievable, but it's not all the way through. And certainly if you're bringing in some crop material, fruit and veg, for example, from Africa and other places, you may have a real problem. You may have a real problem from some of the data that's around, but I don't think the EU will really care about that, to be honest. So just reiterate, the default MRL is 0.01. The Drinking Water Directive has been reviewed. It's a refit, so it's a whole thorough review, massive document. Lots of confusion still reigning about what the MRL for drinking water for chlorate and chlorate will be. It's the first time it's gone in there. WHO gives a guideline of 0.7 ppm, and they consider also how many cases of cholera were we going to get if we had no or under chlorination of drinking water and throughout the food chain as well. So they've come up with this level, and from when I last heard, it was pretty much about half of that's been talking about as an MRL in the Drinking Water Directive, but it's a bit unclear, and as I said, there's intense pressure to get all these things wrapped up quick before summer. So what do we do if we lose hypochlorite? I mean, it's bad enough with the quats thing going on, but you can still put that down the drains, which is where you really need to do a lot of stuff with listeria as well as food contact. I have a question here about validated methods, including extraction, but we've just heard about that. The labs, 17025 is the overall laboratory accreditation. It doesn't address these things. So you need specific accreditation for a method, and now there's a new version 10 of this out. So you need to determine that the latest version with specified extraction methods and all the checks and balances is being used. Otherwise, it's going to be a waste of money. We've still got the question about composite foods, because they're not listed in 396/2005. And just an example of what we're talking about here. So taking a sandwich, so it's got the bread, so the grain, there would have been some sort of irrigation of crops going on there. How much is in the grain? There's butter, which is normally used in my industry, or margarine. So the butter will carry through from the milk and the contact from the dairy sector from the surfaces that they're keeping clean, or margarine as well. Margarine has water too. For fresh produce, we're very aware of this, everything from irrigation onwards, cleaning of crates and surfaces that are in contact at the point of harvest, and then storage, and then of course washing as well, and further preparation of contact with surfaces. Protein, everything through from the feed going into the chicken and the water going into the chicken or whatever animal, it will carry through and then onto the food contact surfaces that the meat is then put onto. And dressings, there's moisture in that too, so it's coming out of the tap. You have to use potable water in the industry, it's coming out the tap. So the sources of residues, the feed, the water, the food contact surfaces, disinfectants and sanitizers. So you get the multiple effect of where is it coming from in this lettuce and looks like a chicken and tomato sandwich with a bit of onion. Where is it coming from? It will be on the outside of the bread on the conveyor belt if you haven't managed to get rid of everything, all the traces. But the thing is, if you wash off biocides, you are greatly encouraging listeria to take hold because it's motile. So if you haven't absolutely sterilised, and through recontamination of the, say, a conveyor belt from the food stuff that's going on, because it's present in food, occasionally at low levels, you will get biofilms and things growing up. So we really need to keep everything clean all the time and not just do a big burst now and then. So this means leaving yourself open to getting traces on the food. So what do we want? A bit of rationality would be great. Rational basis for regulation and enforcement. We must protect public health. We have to, under law, protect public health in all respects. You want to full risk assessment, so the biocidal products regs and PPP do continue and will continue under the BPR to look at hygiene. We can't have the PPP acting alone and compromising hygiene just because we haven't considered the impact of it there. Non-pesticide use of biocides should not be regulated as if it were pesticides, but it should be as a contaminant because it's not intentionally added to the food. We need clear enforcement guidance and a rationale. We need a position from the EU on composite foods. We need to avoid member states gold plating. We really do. We need an agreed method of determining chlorate in different foodstuffs that everybody uses and nobody is using stuff that won't give you a proper result, comparable results. And then we have the B word. How do we minimise regulatory divergence? This is assuming it happens, of course. How do we minimise regulatory divergence as the UK? And then the FBIG guidance on cleaning and disinfection, that has been taken up through the Global Food Safety Initiative, who set up a biocides group that I found myself on, so hence it got put into their documentation. And this is about how to use biocides effectively and responsibly and reduce and minimise trace levels going onto the surface and therefore carry over. So that was all agreed a couple of weeks ago. The GFSI, I haven't seen the final version of it yet, but it'll be coming out soon. And the main point at the end really is going forward, European federations have a major lobbying role post-Brexit. We really need to have our European federations picking up a gear or two and making representations. And as I said, only the UK has really led on this and pushed hard to get activity going on. So we've got a lot of work to do going ahead. And I'll wrap up there and I'm happy to take questions.
Thank you, Karen. That was really good. I'll find out if we've got questions here. Any questions from our audience? No questions so far. No questions so far, but we can wait a minute to see whether we get a question or not, because apologies, we've overrun and it's partly because of my fault. I took more than 10 minutes for my presentation, but it is the first time we've run these things. And sometimes it's time to just change screens with our speakers. So this brings us really to the end of our March 2019 Microbials webinar.
I need to leave now as well.
Yes, so talks have been recorded if you need them. Afterwards, they'll be available on our website. Thank you, Karen. Thank you, Mabel. And thank you to all our delegates. We hope you found these webinars useful. Please do send any feedback or feedback to me at grace.choto@ahdb.org.uk so we know, to run them or not in the future. Thank you very much. Have a good afternoon. Goodbye.